derivatives. So last time you'll remember I covered section 6.1 and I started 6.2. I did a few problems. I want to just do a couple more examples from 6.2. And remember that was on finding partial derivatives. In particular, we were looking at second order partial derivatives. So I'm taking this example from your homework, and we're in section 6.2, and I'd like to do homework problem. Hold on, let me find it here. Got to get to my notes. Kind of rushing around this morning, wasn't really ready, but I'll find my notes here. All right, this is like homework problem number 14. And we are asked to find, in the problem, find fxx, fxy, fyx, and fyy. Now let me refresh your memory on these. The function that we're given here is a function in two variables, and it's 3y ln x. And these are second order partial derivatives. Second order because we have differentiated twice. First with respect to x, then again with respect to x. Here we've differentiated first with respect to x and then with respect to y. Here we're differentiating first with respect to y, then with respect to x, and then both times here with respect to y. Okay, for this function. Now what it means to differentiate with respect to a certain variable is that you hold the other variable constant. So you treat it just like if it were a number like 3. So when we're differentiating with respect to x, so the first time, here's my function, I'm going to differentiate with respect to x. I'm going to hold my y constant. And remember the rule for differentiation, there's the constant multiple rule. So since I'm treating y as a constant, I can bring that out of the derivative. So because this is multiplied by a function of x, I'm going to bring it out and then differentiate with respect to x. Now this notation, remember this is not a 2, this is a fancy d. And the reason why I draw it in a script form like that is because I'm doing a partial derivative because I have two variables. So I'm taking the derivative of the natural log of x, and you will recall from the derivative rules that this is just 1 over x. So this becomes 3y times 1 over x. And then you can just write that as 3y over x. So now I have found the first order derivative with respect to x. Okay, now in order to find fxx and fxy, I'm going to take this new function. So I'm just going to write it down here. And I'm going to this time differentiate with respect to x. I've already done it, differentiated with respect to x one time. Now I got to do it again. So I'm going to take the derivative, and we're talking about fxx. I'm taking the derivative with respect to x of this. Okay, now when you're taking the derivative with respect to x, you treat y as a constant. So remember that 3 and y are both constants. So I can pull this out, and this is going to become 3y times the derivative of 1 over x. Now, in order to differentiate this function with respect to x, I want to write this as a power. So I'm going to write this as 3y times the derivative, whoops, it's supposed to be a d, with respect to x of x to the minus 1. Now that I've written it as a power, I can go ahead and apply the power rule for this, and it becomes minus 1 times x to the power of negative 2. Why negative 2? Because I'm taking negative 1, and you always subtract 1 from the exponent when you're applying the power rule. So this becomes negative 2. Okay? And then when I simplify this, I'm going to have negative 3y over x squared. So x to the negative 2 just means, this negative just means you take the reciprocal. So that's going to throw the x squared in the denominator. Okay, so now I have found the second order partial derivative, which is my fxx right here. Okay, so we've found the first one. Now we're going to move on to fxy. Here's fx. I'm now differentiating it with respect to y. So fxy is the derivative with respect to y of fx. And just notice that this y corresponds to that y there in the notation. This then is the derivative of, with respect to y, of 3y over x. Okay, this time we're differentiating with respect to y. So that means that x is constant. I'm writing this out so that you should write this out too in your notes, because when you go back to this to do your homework, you're going to need these little bits of information to help you work through it, okay? Now, since we differentiated, and I write with respect to, I should say not past tense, we haven't done it yet, but now since we differentiate with respect to y, we hold x constant. Okay, so since x is constant and we're multiplying 3 over x by y, we can pull the 3 over x out of the differentiation because that's the constant multiple rule that we've been using in the past. And now we're just going to differentiate our y. Okay, and the derivative of y is just 1. So this is going to be 3 over x times 1, which is just 3 over x. So we have that fxy is 3 over x. There's the second order partial derivative that we're looking for. Okay, now let me give you a moment to ask any questions. Does it make sense? I know this is kind of just one added level of difficulty, you know, trying to treat a variable as a constant. That's maybe stretching your mind a little bit. I know just learning the derivative rules was bad enough, and now you're having to do this, but I'm trying to give you every single step along the way. So when you go back and review your notes, you can see the progression of what I'm doing here. And the key word is I'm treating variables as constants. Okay, here I'm treating y as a constant because I'm differentiating with respect to x. Here, same here. And down here, I'm treating x as a constant because I'm differentiating with respect to y. Okay, so that's how we do it. Now we've just got half of the problem done. The next step now is to calculate the second order derivatives fyx and fyy. But before I can do that, I have to find fy. So fy is the derivative with respect to y of my f. F is 3y ln x. Okay? And I'm just going to put a little note down here. That's our original function, fxy. All right. So this time, since we're differentiating with respect to y, we hold x constant. Okay? And since x is a constant, the natural log of x is also a constant. It's like taking the natural log of 3 or 2 or something like that. You just put it in your calculator and out comes a constant number, right? So this here is a constant, or we treat it that way. So we bring that out. We can also bring the 3 out. And what's left is the y. So we're going to differentiate the y. And this, of course, is 1. The derivative of y is 1. So we're going to get 3 ln x times 1, which, of course, is just 3 ln x. So now we have found fy. Oh, no, this is just fy, not fyy. Fy is equal to 3 ln x. Now we're going to use this for finding the second order derivatives, okay? So I'm going to start with fyx, which is the derivative with respect to x of this. Now, since 3 is constant, I can pull that out. And so you're just taking the derivative with respect to ln x. And remember, the derivative of that is 1 over x. So you get 3 times 1 over x, and that's just 3 over x. So fyx is 3 over x. And at this point, you'll notice that fxy and fyx are the same. And that's typically, at least for our purposes, that's always going to be the case. You might have some really weird functions that would not behave that way, but for this course, you can always double check and make sure your answers for fxy and fyx are identical. Okay, finally, we're going to do fyy. And so we're going to differentiate our fy function, which is 3 ln x, and we're going to differentiate that with respect to y. But remember now, x is treated as a constant. So that means this whole thing is a constant, and the derivative of a constant is 0. So your fyy is simply 0. And that is the completion of this problem. So if you take a look at your homework, there are a lot of problems like this where you're asked to find all 4 second order derivatives. And you can see just based, here I'm doing just one simple problem, and I'm taking up a whole page of writing here. So these homework problems are kind of involved that way, and this is section 6.2 that I'm talking about. So you want to go ahead and maybe start that assignment 6.1 and 6.2, because those are both due Monday. You don't want to put it off till the last minute. There's kind of a lot of work here. And I find that students find this particular concept challenging. So just kind of a forewarning, don't wait till the last minute to do your homework for Monday night. Any questions on this problem here? Okay, so that was like problem number 14. So that's one less problem you have to do. I mean, you might have to change a few numbers because sometimes, you know, they're drawing it from a pool, so they might change the 3. The 3 might be a 5 or something like that. But any questions on this one? All right, there's another homework problem that I'd like to do that I find that in the past students have struggled with. So I just want to kind of show you not how to do it. It's actually easier than it looks. Okay, this is homework problem number 2 from section 6.2. And the function that we're given is fxy is equal to the square root of x squared plus y squared. All right, and we're asked to find fx, fy, fx31, and fy7 -6. Now, like I said, for you, these numbers might be a little bit different, but you can follow what I'm doing here for the most part. So we're taking, first we're going to find fx, okay? So fx means that we're going to differentiate with respect to x of our f, which is just the square root of x squared plus y squared. Okay, and then when we differentiate that, we want to write this as a power because we're going to apply the power rule. And so we're raising that to the 1/2 power. Now, when you differentiate, since we're differentiating with respect to x, just remind yourself that y is held constant. And so we have, I'm going to do it over here, 1/2 x squared plus y squared. I'm just using the power rule. Now I subtract 1 from the exponent, so 1/2 minus 1, right? And then we have to apply the chain rule, and that's going to where you take the derivative of the inside. Okay, inside the power here is this function, x squared plus y squared. We're taking the derivative with respect to x, so y squared is constant. So the derivative of a constant is 0. So I don't really have to worry about this piece right here. The derivative with respect to x of x squared is simply 2x by the power rule. So I'm going to multiply by 2x because the chain rule tells us we have to multiply by the derivative of what's inside our function. Now you can see the 2's cancel. And of course, we're going to write this 1/2 minus 1 is -1/2. So this is going to become x squared plus y squared to the -1/2 power. And then we still have the x there. Okay, times x. And to simplify this, the 1/2 means I'm going to take the square root of this thing. And the negative means I'm going to put it in the denominator. And then multiply x. So here it's going to equal x divided by the square root of x squared plus y squared. There we have it. That is the first partial derivative of f with respect to x. And I write that f little x there. Now, the next step, so we've got this first thing. The next thing is to differentiate the exact same function, but this time with respect to y. So here I have fy is equal to the derivative with respect to y of this function, which is the square root of x squared plus y squared. And of course, I want to write that as the derivative with respect to y of x squared plus y squared to the 1/2 power. Then I go ahead and differentiate, and that means 1/2 comes out front, x squared plus y squared to the minus 1/2 times the derivative of the inside. The derivative of x squared plus y squared is simply 2y. And that's because this time x is held constant. And the x squared, since x is held constant, this is a constant, and so we just take the derivative with respect to y. That's going to give me 0 for this piece. Here, the derivative with respect to y is 2y, so I multiply that by the chain rule. And as you can see, the 2's cancel just like they did here. So we're going to then write this as Fy is equal to, the y is in the numerator, and because of this negative, this piece is in the denominator. And because of the 1/2, we're taking the square root. So this is my Fy. So now I've found the second part right there, okay? Okay, and now I want to find Fx 3, 1. Well, 3 is our x, 1 is our y, so we're just going to take those values and substitute them into this function, right? This is my Fx. So, Fx of 3, 1, I'm just going to write a note down here. X is equal to 3, y is equal to 1. And so plugging it in here, I have 3 over the square root of 3 squared plus 1 squared. And so I'm going to have 3 over the square root of 10. And of course, you want to rationalize the denominator. So you have 3 square root of 10 over 10. So we have that piece. And finally, we're going to evaluate Fy at 7, negative 6. So this time we're evaluating Fy. Fy is right here. So y is negative 6, and the 7 is the x, so that's going to be 7 squared plus negative 6 squared. And this is going to be 49 plus 36. That is going to be 85. Okay, and of course, to rationalize the denominator, gives us negative 6 square root of 85 over 85. And that completes our problem there. Okay, any questions on this? I hope by going through this with you step by step, you'll start to get the hang of it. And it's just going to take practice. So really take the homework, just don't, a lot of times we rely too much on the question help and we just follow the pattern and we do it without really thinking about what we're doing just to get the homework done. Try not to do that, okay? Try to honestly do the homework on your own without too much help. I know this stuff is tricky, so yeah, you are going to have to look at the notes carefully and you probably will need to use the question help. But when you get to the quiz, try to do it on your own, okay? And you'll get the hang of it. Of course, you need to know your derivative rules, all right? So, well, that concludes section 6.2. So I'd like to move on to section 3.1.